Hello, everybody. I'm Hao Nguyen. Today, I'm gonna read to you the news on the ideas.ted.com. Is climate change making tornadoes worse? Here are three things that scientists know. Now, here we go. You can see that here is the picture of a huge tornado. The deadly tornado outbreak that tore through communities from Arkansas to Illinois on the night of December 10 to 11, 2021 were so unusual in its duration and strength that a lot of people, including the US president, are asking what role climate change might have played, and if tornadoes will become more common in a warming world. Both questions are easier asked than answered, but research is offering new clues. I'm an atmospheric scientist who studies severe convective storms like tornadoes and the influences of the climate change. And here's what the scientific research shows so far. Number one, tornadoes are super hard to predict. To understand how rising global temperatures will affect the climate in the future, scientists use complex computer models that characterize the whole Earth system, from the sun energy streaming into how soil responds and everything in between from year to year, season to season. These models solve millions of equations on the global scale. Each calculation adds up, requiring far more computing power than a desktop computer can handle. Think of predicting tornadoes like the zoom function on the camera looking at the distant mountain. You can see the forest, but individual trees are harder to make out. The project How Earth's Climate Will Change Through the End of the Century, we currently use the broad scale. Think of it like the zoom function on the camera looking at the distant mountain. You can see the forest, but individual trees are harder to make out. And a pin cone in one of those trees is too tiny to see even after you blow up the image. With climate models, the smaller the object, the harder it is to see. Tornadoes can to severe storms that create them are far below the typical scale that climate models can predict. Instead, we can do is look at the large-scale ingredients that make conditions ripe for tornadoes to form. Two key ingredients for severe storms are number one, energy driven by warm, moist air promoting strong updraft, and number two, changing wind spread and direction, known as wind shear, which allows storms to become stronger and longer lived. A third ingredient, which is harder to identify, is a trigger to get storm to form, such as a really hot day or perhaps a cold front. Without this ingredient, not every favorable environment leads to severe storms or tornadoes, but the first two conditions will make severe storm more likely. By using these ingredients to characterize the likelihood of severe storms and tornadoes forming, climate model can tell us something about the changing risk. Number two, climate change is projected to increase the frequencies of the severe storms. Climate model projections for the United States suggest that the overall likelihood of favorable ingredients for severe storms will increase by the end of 21st century. The main reason is that warming temperatures accompanied by increasing moistures in the atmosphere increase the potential for the strong updrafts. Rising global temperatures are driving significant changes for seasons that we traditionally think of the rarely producing severe weather. Stronger increases in warm, humid air in fall, winter, and early spring mean there will be more days with favorable severe thunderstorm environments. And when these storms occur, they have their potential for greater intensity. Only a small fraction of the storms produced in a favorable environment will produce a tornado at all. Over smaller areas, we can simulate thunderstorms in these future climates, which gets us closer to answer. Several studies have modeled changes the frequencies of intense storms. To better understand this change to the environment, we are already seeing evidence in the past few decades of historic conditions more favorable for severe storms in the cooler season, while the summertime likelihood of storms forming is decreasing. But for tornadoes, things get trickier. Even in an otherwise spot on the forecast for the next day, there is no guarantee that a tornado will form. Only a small fraction of the storms produced in favorable environments will produce a tornado at all. Several simulations have explored what would happen if a tornado outbreak or a tornado producing storm occurs at a different level of global warming. Projections suggest that stronger tornado producing storms may be more likely as a global temperature rise. Through strengthened less than we might expect from the increase in available energy. Number three, but there is a lot of scientists are still trying to figure out. Much of what we know about how warming climate influences severe storm and tornadoes is regional, chiefly in the US. Not all regions around the globe will see changes to severe storm environments at the same rate. It remains difficult to attribute any single event like this one to climate change. In a recent study, colleagues and I found that the rate of increase in severe storm environments will be greater in the northern hemisphere, and that is increased more at higher latitudes. In the US, our research suggests that for each 1 degree Celsius, 1.8 Fahrenheit, that the temperature rise, and a 14 to 25% increase in favorable environment is likely in spring, fall, and winter, with the greatest increase in the winter. This is driven predominantly by the increasing energy available due to the higher temperature. Keep in mind that this is about favorable environments, not necessarily tornadoes. To answer whether climate change influenced the likelihood or intensities of tornadoes in December 2021 outbreak, it remains difficult to attribute any single event like this one to climate change. Shorter-term influences like El Nino Southern Oscillation may also complicate the picture. There are certainly signals pointing in the direction of the stormier future, but how this manifests or tornadoes is an open area of research. Thank you so much for your listening. Bye bye for now and see you in the next video. Goodbye. See ya.